Good day everyone, this is Shanna from BSIT4C and today I will discuss to you about the hierarchical clustering analysis. Hierarchical clustering analysis is a general approach to cluster analysis in which the object is to group together objects or records that are close to one another. So it says here that hierarchical clustering analysis is an algorithm that groups similar objects into groups called clusters. A key component of the analysis is repeated calculation of distance measures between objects and between clusters. Once objects begin to be grouped into clusters, the outcome is represented graphically as a dendrogram. So this simply means that the endpoint is a set of clusters where each cluster is distinct from each other cluster and the objects within each cluster are broadly similar to each other. For you to know what hierarchical clustering analysis means, I'll show you an example here. So let's consider that we have set of cars here and we have a group similar. We want to group similar ones together. So below, we have set of cars down there and we get two clusters of car, which is sedan and SUV. And last, we can group everything into cluster. So we just have just cars. This is very common we see in any by touch. By hierarchical clustering, this is you see which is seen what comes out of it. So we terminate when we are left with only one cluster. So we have, as you can see, we bring them all together. We have one cluster and we can't bring them all together anymore because they're all together, them different. So when we say agglomerative clustering, it is known as bottom-up approach, and this is the most common type of hierarchical clustering used to group objects in clusters based on their similarity. And when we say divisive clustering, it is a top-down clustering approach. Initially, all the points in the dataset belong to one cluster. Split is performed recursively as one moves down the hierarchy. To explain how hierarchical clustering works, we will use the following dataset that comes from measurements on 5 different individuals A, B, C, D, and E. This row shows the diastolic blood pressure of the 5 individuals, whereas this row shows the systolic blood pressure. We also have data on the body weights in kilogram and body and heights in centimeter, as well as the total cholesterol level in the blood of the 5 individuals. Let's place the data table up here. The following profile plot of the 5 different variables will help to understand how clustering works. For example, this point represents the systolic blood pressure of person A, whereas this point represents the systolic blood pressure of person B, and so forth. Let's say we like to group variables that have similar values. For example, it seems reasonable to group the total cholesterol level with the body height and the variables body weight and diastolic blood pressure because these pairs of variables have similar values. Similarity between two variables or two objects is usually measured by calculating the distance between the data points. For example, how would you calculate the distance between these two data points? One way to calculate the distance between these 2 points is to sum the horizontal and vertical distances between the 2 points. This can be seen as the walking distance between 2 points on Manhattan. Such type of distance is usually called Manhattan distance. So here, when you are moving from bottom to top, this is called as agglomerative, and when you are moving from top to bottom, this is called as divisive, and this representation is called dendrogram.